Hello, everyone. Welcome to this lab. This is Hooke's Law lab. To do this lab, you need a stand, you need a spring, you need a metal stick, okay, to measure the length, and also you need a mass. You're gonna be hanging on the spring, and to measure the length, the new length, or how long the spring will stretch every time you add those mass to it. You also need a hanger. The hanger itself has a mass, and you're gonna hang the mass to the spring. The spring will stretch when you hang the mass to it. You're gonna also measure that length. Okay, those are what you need in order to actually perform this lab. By the end of this lab, you're going to have a data. A data you can use to actually plot a graph. And that graph will be used to determine the, the spring constant. Now, concerning the procedure of the lab itself, the first thing you do is to measure the length of the spring. Okay, so the length of my spring from the bottom, the spring up is 30, 30.5. 30.5. You have to make sure everything is done properly. It's 30.5 centimeter. Take a note, 30.5 centimeter. Okay, that's the initial length of my spring. I'm gonna hang the hanger, okay, the mass hanger, okay, to my spring. Notice that the spring stretch to a new length. Going to measure the new length of my spring. Okay, I stretch it to 30, 31 centimeters. So now I have a series of 1, 2, 1, 2, 3, 4, 4, 5. Okay, mass I'm gonna hang to the hanger and to measure the new length of my spring. Okay, so I just want to remind you, because before I start hanging those mass, that the mass of the hanger itself is 50 grams. Now add to the 50 gram, this is my first mass of this 100 gram. I have now a mass of 150 gram. When I hang the 50 gram, the first one, my spring or the spring stretch to 31 centimeter, from 30.5 centimeter to 31 centimeter. Now I hang 150 gram. I have 150 gram on it. Stretch to 36 centimeter. Hang another 100. That's now I have 250. 250. Stretch it to 41 centimeter. Have another one, add to it. Now 350 gram. Stretch it to 40 47.5, 47.5 centimeter. We'll have a total of 450 gram. Stretch it to 53 centimeters. The last mass, stretch it to 60 centimeters. So you can see yourself that as we increasing the mass, uh, we hang to the spring. The spring length is increasing. The force, okay, applied to the spring, which is the weight of the mass that came from the mass we are hanging on. The hanger is actually proportional to the stretch of the spring. That's Hooke's law. Okay, so anytime you apply a mass, you calculate the weight, which is the force. That weight is equal to a constant that multiply the difference, in the length, okay, or the change in length, okay, the change in length at the spring. So the change in length, anytime you hang a mass, the initial length of the spring, which is 30.5 centimeters, should be subtracted or deducted from the new length. Anytime you hang, you have to deduct that initial length from the new length. That will give you the distance stretched. So the weight applied is equal to a constant K multiplied by the distance stretched. That's Hooke's law. So by the end, you should be able to draw a graph of the force apply Vs, the distance stretch, and the slope of the graph should help you to calculate the spring, the constant. If you determine the slope of the graph, okay, you get from drawing the force Vs, the distance stretch. When you calculate the slope of that graph, okay, the slope of the graph should be actually the spring constant. Okay, so thank you for your attention.